Hello, everyone. Today we are continuing our study with exponents. So right now, I want you to remember our rules we learned yesterday. Okay, so remember we learned yesterday two rules that when we're multiplying, so x to the a times x to the b, that's equal to x to the a plus b, and x to the a to the b is equal to x to the ab. We also learned that when we're doing a power to a power, if there's more than one inside the parenthesis, you multiply all the exponents of each base. So today we're going to talk about quotient of properties. So the quotient of powers for all integers m and n and any non-zero number a to the m over a to the n is a to the m minus n. So you subtract. So when we're multiplying, we keep the base and add the exponents. When we're dividing, we keep the base and subtract the exponents. And the same rules for the power of quotient is if we have any integer m and any real numbers a and b, a over b to the m in parentheses, we give that exponent to each thing. So examples. So we want to simplify a to the fourth b over ab squared, and we're assuming no denominator is 0. So what we do is we treat each base separately. So I have a to the fourth over a, so those are like bases. So I keep the base and subtract. When there is no exponent, remember there's a 1. So 4 minus 1 is 3. Then I do the same with the b's. And this is supposed to be b to the 7th. So it's b to the 7th over b squared, so that's b to the 5th. Number 2, here we have it being raised to the third power. So there are two ways you can do this. You can simplify what's inside first and then raise everything to the third power, or raise everything to the third power and then simplify. I'm going to simplify first, if I can, what's inside the parentheses. So I have parentheses. So the 2 over 3, I can't simplify that because that's division. And 2 over 3, that fraction is simplified. There is only a cubed. That's the only base of the a, so it's a cubed. And then the b's, I'm dividing b to the 5th by b squared, so that's b cubed. And I'm giving that all to the power of 3. Now I'm going to give each base the exponent of 3 by multiplying the exponents. So 2 has an exponent of 1, so that's 2 cubed. A has an exponent of 3, so I multiply 3 times 3, the 3n, so that's a to the 9th. B has an exponent of 3, so 3 times 3 is b to the 9th, over 3 to the 3rd. Now, we should do 2 cubed, which is 8, over 3 cubed, which is 27. Okay, so now let's do some other examples. So number 1, we have the same base of 5, so I keep the base and subtract the exponents. 5 minus 2 is 3. Number 2, we treat each base separately. So we have the base of p, so we keep the base of p and subtract our exponents, so 5 minus 2 is 3. Then we have a base of n, which we keep the base and subtract. Remember, the n in the denominator with no exponent really has a 1, so that's n cubed. Number 3, we have x to the 5th over x to the 5th. Well, anything divided by itself, you know, is 1. So that equals 1. So it's really just y, because y cubed over y squared is y to the 1st. So I want you to pause, and I want you to do questions 4 through 9 and come back. Okay, so number 4, first thing I did is I reduced negative 2 over 14. Negative 2 over 14 reduces to be negative 1/7. Then I kept the base of the y to the 7th divided by y to the 5th is y squared. Number 5, x divided by x, because they have no exponent, is 1. Y to the 6th divided by y to the 4th is just y squared. 6, I simplified what was inside first. So it's 2ab, because a squared divided by a is a to the 1st. I then cubed everything inside the parentheses. So that's 8a cubed b cubed. 7, again, I simplified what's inside first. So p to the 4th divided by p squared, I keep the base, I subtract the exponents, p squared. R to the 4th divided by r squared, I keep the base, subtract, that's r squared. I then cube everything, so it's 64 p to the 6th, r to the 6th over 27. 8, again, I simplify inside. W cubed divided by w cubed, that's 1, because anything divided by itself is 1. 2, r to the 5th divided by r to the 4th is r, so that's 2r to the 4th, so that's 16r to the 4th. 9, what I did first is I rearranged them in alphabetical order so that like bases were above each other. So n to the 7th divided by n cubed is n to the 4th. R to the 7th divided by r cubed is r to the 4th. And t squared over t squared equals 1. Now, you noticed above that when I had w cubed over w cubed, I said it equaled 1. Well, if I use my exponent rules, when I keep the base, I subtract and I get 0. Well, that does equal 1 because 0 exponent for any non-zero number, a to the 0 equals 1. Then we also have for any non-zero number, a, and then the integer n, a to the negative n equals 1 over a to the n. It's the reciprocal. You flip it. The negative exponent means you flip it. So let's try this example. So the first thing I'm going to do is I'm going to do my 4 over 16, which reduces to be 1 over 4. I then keep the a of the base, and I keep the base and subtract. So I'm going to do negative 3 minus 2, because I always subtract numerator minus denominator. So that's a to the negative 5. B to the 6th over b to the 6th is b to the 0. And then there's c to the negative 5 in the denominator. Now I need to simplify that more. So 1 over 4, that's still 1 over 4. A to the negative 5, that's a negative exponent. Negative exponent means write it as the reciprocal. So it goes to the denominator, and that makes the exponent positive. So a to the negative 5 is the same as 1 over a to the 5th. B to the 0, that's 1, and I'm multiplying, and then c to the negative 5 is in the denominator. So again, negative exponent means reciprocal. So that means c to the 5th is in the numerator. And that is my answer. Or I don't have to write the 1. It would be c to the 5th over 4a to the 5th, because anything times 1 is the anything. So we have 10 examples of these. So I'm going to do the first 3. Or actually, I want you to pause, do the first 6, and then I'll come back and do the last 3 with you. Okay, so number 1, I keep the base and subtract. So 2 minus negative 3 is 5. So it's 2 to the 5th. 2, I keep the base and subtract. So that's p to the negative 11th. I can't have a negative exponent. So I write that as 1 over p to the 11th, because negative exponent means reciprocal. Number 3, I keep the base of b and I subtract the exponent. So it's negative 4 minus negative 5, which is 1. So it's b to the 1st, or just 1. My numerator here is all being raised to the 0 power. Anything to the 0 power equals 1. My denominator I left alone. Then I looked at my denominator and I have w to the negative 1, which means negative exponent, so it's the reciprocal. So my final answer is w over 4y squared. Number 5, I first did the power to the power in the numerator and denominator. So my numerator became a to the 4th, b to the 6th, over a negative 2, b to the negative 2. Then I kept the base and subtract. So it's a to the 6th, b to the 8th. Number 6, y to the 0 is just 1. X to the 4th over x to the negative 2 is x to the 6th. So number 8. Again, first I'm going to do the power to the power. So 6 squared is 36. A to the negative 2, b squared over b to the 8th. So now I'm going to do my division. So that's 36, a to the negative 2 over b to the negative 6, because division, you keep the base and subtract the exponents. I now have two negative exponents, so the 36 remains in the numerator. A to the negative 2 becomes 1 over a squared. B to the negative 6 becomes 1 over b to the 6th. And that is my answer. Okay, so number 9, here I'm going to do this a little differently because the power to a power is really just to a negative 1. So that means reciprocal. So I'm going to leave the numerator alone. And then reciprocal means that the m squared t cubed comes to the numerator. Now I'm going to multiply. So m to the negative 3 times m squared is m to the negative 1. T to the negative 3 times t cubed is t to the 0, so that's 1. So m to the negative 1 is equal to 1 over m. 10, anything to the 0 power is 1. So that's the end of our video for today. If you have any questions, please bring them to class.